I'm going to start the recording. So we're talking about plumbing prints. So what are our goals for the balance of this evening and next Thursday would be to identify various different types of piping systems, recognize plumbing fixture symbols on prints, explain the 3 stages of plumbing installation, and read a piping diagram. And in plumbing, we'll see something that we have not seen before. We'll see this isometric. So we'll see some information on plumbing drawings presented both in plan and also in isometric. Isometric is a drawing technique that helps us visualize what's going on in a plumbing system, and some mechanical systems will be shown in isometrics as well. So again, we are on stage 1, 2, and 3 on page 229. So in general, we have 3 stages of a plumbing installation. Stage 1 would be what's done prior to the pouring of the foundation, right? So what's happening underground. So prior to pouring the foundation wall, we want to make provisions for the service entrance. Service entrance typically means the connection that's made from city water to the building, and provisions for sewer drain made. Again, sewer drain would be the connection from the building back to the city sewer. You know, if we happen to be building in a place where there isn't city water, if we have well or we have septic on the sewage side, then we might do something different. But generally speaking, the site plans will show where the mains are in the street and tell the plumbing contractor what size connection to make between the water main out in the street or the sewer main in the street and the building. Stage 2, and we'll see some pictures in just a minute, completed prior to pouring the slabs and putting up the wall covering. So stage 2 is often called a rough-in or rough-in plumbing. And in this case, we're going to start connecting up the supply and the drainage pipes. And then stage 3 would be after the walls and floors are put in, the plumber is going to come back and essentially hang the fixtures on the rough ends that he or she has put up previously. Right, so this is stage 1. This is also figure 13-2 on page 230. Right, so this would be the piping that's being put in underground, below grade, before the floor slab is poured. Right, so the plumber has to get in there and lay the drain piping and any water supply piping that is shown on the plans to be underground. Right, plumber's got to get there before the concrete contractor comes, otherwise he or she's going to have trouble knocking through the concrete slab to get his or her piping in place. Here's stage 2. Again, this is figure 13-3 on page 230. This is rough-in. So in this case, you see that there are some walls up. Either the floor slab has been poured, or in this case, the gravel has been put in place and compacted. And now the plumber, he or she is working up from the stubs that he or she placed previously. And is, yes, in essence, this is going to be the piping that's going to be, this appears to be commercial construction. So as we see when we look at commercial construction, this is probably piping that's going to be in what's called the wet wall. So this piping system is probably larger than what could be contained in a residential 2x4 stud wall. So the wet wall probably has a opening dimensions greater than the 3.5 inches in a 2x4 stud wall, and we'll see that when we get to some of the commercial plumbing projects. But again, this, the piping that you see running vertically is going to be, in the stud wall or the wet wall, and these little horizontal things poking out will be the rough ends that will extend through the wall and make the final connections to the fixtures. So if you think of sequencing here, right, the plumber is going to get here and do the rough in, and then once the plumber is done, he or she is going to go away and the next trade will come in. And this, judging by this picture, I'm going to guess that there'll be a concrete slab poured over this compacted gravel. And once that concrete is cured a little bit, then the next trade will come in. If it's if these are masonry walls, then the mason will come back and build the masonry walls, or the carpenter will come if they're wood frame walls. And then in stage 3, and I don't know where my picture went. Actually, I don't have a picture for stage 3. Stage 3 would be the
Mr. Becker?
Yes, sir.
Sorry, yeah, so the carpenter's in charge of drilling the holes, or has to drill the holes if it's commercial?
Yes, I would say generally speaking, yes. The trades, all kind of have their jurisdictions of what they do and what they don't do. Some of those little details are often ironed out in the field, but I would say yes. Let's say if this is masonry construction, the mason is going to have to make provisions in their block wall to allow this pipe to come through. So they're going to be laying a block wall up, and they're going to either probably drill a hole in the wall or split the block in two. My guess would be they'll split the block in two and go around the places where the plumber has put the rough in. So the plumber is not going to cut holes in the mason's concrete block. The mason is going to work around the rough in that the plumber's already made. Or in the case if this was frame construction, the framing contractor, the carpenter is going to come in and frame the wall up. Let's say this is drywall, then who's ever hanging the drywall is going to have to make a hole in the drywall to accommodate that the plumber's rough in.
Yeah, okay, so like in residential, like when we're framing or whatever, the plumber is drilling the holes for the plumbing, but you're talking about like the mason will have the pipe stick out if it's a mason wall. Okay, now I know what you're saying a little bit too. Like the drywaller drills the holes for it to go through and be able to get the finishes on.
Yes, that's correct. Yeah, I mean, again, like any of this stuff, the trades have to be communicating with each other, and these trades all have to be on their toes, right, so they don't get buried. Right? If you're the plumber, you don't want to get buried by the drywall person, right? You slept through the last week's construction meeting, and you missed when the general contractor said, "Oh yeah, we're the owner wants to accelerate construction, so the drywall contractor is going to show up on Saturday and start hanging drywall, right? If you're the plumber and you were snoozing through that meeting, you come back on Monday and you're like, oh my God, the drywall guy already hung all the drywall and I didn't get my roughing done. So
Yeah. Okay, well, thanks.
you're welcome. Good questions. Again, you just have to think about what's happening in reality, right? What does the drawing say, and how are the various trades coordinating the work? What's happening? What's logically happening in reality to go from this picture to a finished. Let's say this is a commercial building. It could be a school. The finished boys and girls washrooms in a school. Right. So in a plumbing system, we have two different things happening, right? We have hot and cold water being distributed to fixtures, and then we have the drain, waste, and vent piping. So we have the waste being conveyed from those fixtures back to the sewer, right? So on the water distribution side, we have a main supply line coming from the city into the building. From, let's say that there's city main is in the street. We bring water into the building, probably go through some kind of water meter, and then we have to distribute it to all the various fixtures and outlets in the building. Right, we're going to take some of the water is going to go to a water heater. So now we're going to have hot water and cold water, and that has to get distributed to all the different plumbing fixtures that are in the building, be it a sink or a bubbler or a drinking fountain or a water closet or a hose bib, right? All the different types of plumbing fixtures that might be in the building. And in that water supply system, we'll generally have some control valves. We'll have, generally speaking, ways for the people that have to maintain the building. Once all these contractors go away, someone still has to maintain the building. So the operating staff of the building is going to want to make sure there's some valves, some control valves at strategic locations in the building. So let's say if they have to replace a flush valve, or they have a leaking washer in a sink someplace, they can shut off. They can isolate that fixture from the rest of the system and do their repairs. This is a little hard to read. Let me see where this is. This is figure 13.9 on page 235. And it's a little hard to read on the slide. Hopefully you can see it a little better in your book. But this would be the plan view of a water distribution system. And I actually have to bring my magnifying glass out. In plan, I see, right, looking right here, I see a couple different things happening. I see pipes labeled with a couple different symbols, and I don't see anywhere I don't see a key to this drawing, but over in there I see a 3/4 inch HWR, a 2-inch HW, which is hot water, a 2.5 inch CW, which is cold water, and a 2-inch G, which would be gas. So HWR is something that you're going to find in commercial construction and generally not in residential construction. HWR is hot water return. So in a commercial building, you'll often have a hot water return line, which gives you a way to have that hot water moving around in a circle, such that if you're way at the end of the line and you turn on the hot water faucet, you don't have to wait 3 or 4 minutes for the hot water to get from the hot water heater way over on the other side of the building. There's some hot water moving around, then you get your hot water a little bit quicker. So again, this is a plumbing system in plan view. And over here where it says girls, right, this looks like a school. So that's a girls lavatory, with LAB1 would be the lavatory sinks. WC1s and WC2s would be water closets. Again, that's a little hard to read. Certainly you can't see it on this slide here. In the textbook, I actually have to have a magnifying glass to see all the details. But again, this is showing the plumbing system in plan. That make sense? So what are some of the materials that we use for water distribution? We can use copper, we can use galvanized steel, or we can use plastic. And the slide says that copper and plastic are most common for residential installations. That's probably true for today, but if many of you live in older homes, like the house that I live in, years ago when we redid part of our house, we had to change out galvanized steel piping to copper. So you could easily have galvanized steel in an older home as opposed to copper. But copper and plastic are going to be the more common piping materials today. Right, so again, a little more detail on that. PVC or polyvinyl chloride is plastic that's for cold water. CPVC is another form of PVC piping that's rated for higher temperatures. PEX, I think PEX is cross-linked polyethylene. We will often see that for cold water piping or radiant floor, or piping in a radiant floor system, which we'll see when we get to HVAC. Copper, used for both hot or cold water or hot water return. And our galvanized steel that we might find in older construction or commercial construction. We have a number of different types of copper piping, heavy, medium, and light wall thicknesses. You'll see what this looks like in a minute. Hard or soft tempers, right? Different characteristics of copper piping. We, generally speaking, don't embed copper in concrete because it will corrode. Generally speaking, we don't have copper in contact with other metals. Certainly, we have to have what's called a dielectric union if we're trying to join copper piping with galvanized steel piping. Again, different types of metals will have what are called galvanic reactions. Right, one of the metals will disintegrate over time. Copper piping we typically join by sweating. This says threading, but I'll show you a couple different ways that we can join copper pipe. Right, so here's I guess I have to, boom, different types of copper piping, type K, L, and M, distinguished by the color printing on the outside of the pipe. And you see in all these cases, the OD, or the outside diameter of the pipe, is the same. The wall thickness varies. Right, type K is going to be a thicker wall than type L or type M. Obviously, if the outside wall thickness is the same, or the outside diameter is the same, and the wall thickness varies, then the ID, or the inside diameter, is going to vary as well. But again, you see that the K, L, and M are going to be used in different situations, right? We see type K with its thicker wall is going to be suitable for underground service, and the type L or M would be more used for general purpose plumbing, not underground. Again, here's some pictures. You see the different colors on the side, the type L, type M, and type K. So copper pipe is going to look the same, but it'll have different wall thicknesses, and so indicated by the print and color on the side of the pipe. And again, in this case, the OD, or the outside diameter of the pipe, is going to be the same, and the ID varies depending on the characteristics of the pipe. And this flow, GPM means gallons per minute. So this would be the kind of information that the plumbing contractor or the engineer might use to determine what size pipe is required in a certain situation, right? If I have I'm running pipe out to a series of washrooms that have, a couple water closets and a couple lavatories. How big does the pipe have to be, right? We'll see how that's done in just a minute. So copper pipe has both straight pipes and fittings. You see some examples of copper pipe fittings here, couplings, elbows, short radius and longer radius elbows, et cetera, T's. So how do we join copper pipe? Well, a couple different ways of doing it. One is called sweating, and this is a skill that takes a while to learn, but if you're going to sweat copper pipe, you have to cut the pipe to length. You typically have a tool to deburr where you just made the cut. I always learn to clean off the end of that piece of pipe with a piece of emery cloth, and then tin that piece with solder, and put flux in there. And finally, what happens is that this is a torch. The plumber is going to heat up that, in this case, the coupling with the torch, and have that solder. Let me put the pointer back on. Have the solder getting right there, and when the pipe in the joint heats up enough, that solder will melt and get drawn into the joint, and when it cools off, you'll have a good solid connection. So that's called a sweating pipe. And I see that we have come to the end of our time for this evening, so I will pick this up again on Thursday. Any questions so far? Okay, sounds good. Yeah, if I leave you without questions, Nicole, then maybe I've done my job here. Yes, this was recorded, Charlie. I did remember to push the record button, so that's good for me. I will have this posted. I'll try to get this posted tomorrow. For the most part, Charlie, I can't say I've recorded every lecture, but I tried pretty well. I actually learned how to edit stuff on YouTube. You know, these recordings come off a Blackboard, and then I bounce them over to YouTube, and then when you see them on back on Blackboard, it actually has a YouTube link. So I figured out how to do some editing on YouTube the other day. So I think I saw one or two of you who did not do the quiz tonight. So I did not see quizzes from everybody. I think I sent a chat message to the person in particular. So um, I will probably send you an email and ask you what's up. But the rest of you, I will take a look at your quizzes. Any other questions? Okay, we will continue again on Thursday talking about sweating and other ways of putting copper pipe together. Yes, you have a good evening as well, Vaughn. Thank you, Nick. Good night, Patrick and Nicole. Yep, have a good evening, everyone.